We are going to get started with the next session, which is on Hetnets. Hetnets seems to me, as an analyst who's been covering the mobile space for a long time, a slightly outmoded concept or term, but really it's extremely relevant in the sense that we're going to be talking about the convergence of macrocellular, small cell, and Wi-Fi. And if you look at the roadmap for 5G, if you look at what's happening with unlicensed, if you look at how the FCC is looking at some of the new shared spectrum scenarios and so on, these networks are all sort of coming together. And so that'll be sort of the thesis of this discussion. So we have a fireside chat / Q&A discussion with two great companies in this space. I think we'll learn a lot about Hetnets over the next 20-25 minutes. So we have Steve Martin, who is a Senior Vice President and General Manager of Emerging Technologies for Ruckus Wireless, clearly one of the great telecom success stories in Silicon Valley, and Sri Purasai, who is VP and Business Unit Manager for Microsemi, who we understand they're located right next to the Brocade offices, and Brocade just acquired Ruckus not long ago. So these guys, I think, are actually just meeting for the first time, ironically. But anyway, so why don't we start with Steve, and what I'd like each of them to do is just spend 2 or 3 minutes talking a little bit about their role, what their firm does in the space, and sort of how they view, like, where are we with Hetnets right now, and I'm sure that'll start to generate the follow-on discussion. So Steve, why don't you kick things off?
Sure. Thanks, Mark. So as Mark noted, I run emerging technology initiatives for Ruckus. As most of you probably know, Ruckus has been one of the major Wi-Fi providers, particularly in the service provider space. We obviously sell into enterprise as well, but kind of Wi-Fi for service provider has been a well accepted part of Ruckus's role in the industry over the last 5 or 10 years. As you might imagine, we've made a number of leading announcements with respect to this and demonstrations at Mobile World Congress. We're certainly embracing kind of move to, Hetnets, if you will, small cells, if you want to call it something else. As the world is obviously moving to shared radio resources in multiple fashions, I think you can just look at what's going on in the industry today. Some of the initiatives that are out there, LTU, LAA, licensed moving into unlicensed, LWA, LTE, wireless LAN aggregation where you're transporting LTE over Wi-Fi, CBRS, which we are a principal behind that, the just recently announced CBRS Alliance, which is effectively very interesting in terms of pioneering new technology, a whole new initiative in terms of how to share spectrum, which the FCC has been a strong proponent of, and now many companies are signing on to the alliance to drive a new shared spectrum capability. And then, of course, some of the things that are going on in millimeter wave, both now in terms of V-band, and then looking forward as we look at 5G. As you bring that to the access layer, clearly there's going to be RAN sharing, if you will, in terms of multi-RAT types and how to integrate these into seamless user experiences. So, a lot of exciting things going on right now. Very happy to be part of that.
Yeah, no, it's really interesting. If you look at where we are now, even compared to where we were a year ago, there is just a ton going on. And if you can have your opinions either way on the FCC and under Wheeler, but I mean, what they've done with Spectrum this year, just between CBRS, and when Steve talks about CBRS, that's the 3.5 gigahertz initiative, where I think it's 150 megahertz of spectrum,
yeah, that's correct.
On using various scenarios for how that spectrum is shared and so on, PAL layer and all of that. Really exciting, and the opportunity for the U.S. to sort of be at the forefront of innovation on shared spectrum. So we'll get a little bit more into that. But Sri, why don't you tell us a little bit more about Microsemi?
All right. Thanks. Hope you can hear me. This is Sri here.
Mike?
Hello?
There we go.
So the way we look at it, Microsemi is a company that was established in 1959, very old company down in Orange County. Over the last 10-15 years, we've been able to amass enough amount of technology companies that makes us pretty essential as we go towards 5G. In particular, they acquired most of the timing and synchronization parts of the business, and I'm currently running the Symmetricom part of the business. which we acquired in 2013. We do network synchronization worldwide, and the way we look at Hetnet and small cell is yet another change. In the last 40 years, 50 years, we've been part of this transformation from TDM to packet network, and then now we're going from packet to SDN, and also on the radio side, we're going from low frequencies to high frequency, from 2G to 3G, and then going forward to 5G, and more, we feel that the densification and the coverage needs, especially going into enterprises and indoor, is becoming a big challenge. In fact, in our building where I am, on the first street, downstairs, we didn't have any coverage, so we had to call AT&T and Verizon. They came and gave us a quote just to install that DAS radio, $150,000 of quote, which was out of the blue. I mean, just part of the building that had no coverage. This is what you run into, just getting coverage into the building. Wi-Fi doesn't work everywhere. It's great for capacity, but for coverage and managed services,
right,
I think that's a big problem that operators are facing as you go indoors. The other problem that you have when you go into managed services is you can get synchronization for, let's say, a Samsung, Nokia, Ruckus, whatever base station operators decide to use. But the second part of the challenge is when you do E911 issues, when you run into emergencies, in order to finally locate the person that's actually making the emergency call, that's becoming a big challenge, especially when you go into high-rises.
Sure.
In big cities where you have more than 10 floors and people have to be given emergency services in a quick second. That's becoming a big challenge. And so timing and synchronization was relevant, is relevant, and is going to be relevant, more relevant in the 5G realm, and especially going into higher frequencies with LTE unlicensed, and also with other frequency bands. So I think we are just bringing in very critical technology into the market that people don't realize they need it till things start going wrong. Okay. I'll just leave it at that.
So the scenario described with the $150,000 DAS quote on First Street is the business case for 3.5G, which really is all about small cells in buildings and being able to do that on a sort of almost like an enterprise level DAS sort of system.
Yeah, I mean, that's certainly where we see the promise of 3.5, and a lot of other companies, as I mentioned, with the CBRS Alliance now forming, is really kind of a next generation DAS system, really to address the broad cross-section of, if you will, kind of mid-tier enterprise, public venues, places where, it's a BYOD world. I mean, you take this facility as maybe an example of that. I was talking yesterday, I was in a conference in Seattle with general manager of a clothing chain who basically came up with this very innovative in-store coupon delivery to the handset program to incent shoppers to buy things as they got in the store. The only problem they discovered after they designed the whole thing and rolled it out is 10% of their stores had almost zero cellular coverage, so the shopper had to leave the store in order to actually get the coupon. I mean, obviously that's not a great promotion. So I think there's very practical use cases for in-building cellular that just frankly haven't been met by today's solutions.
Yeah. So just going to step back for one moment. Timing and synchronization. Could you tell us in like 45 seconds or less why that's really important in a small cell network or in a heterogeneous wireless network?
Sure. If you heard everything about the discussion so far, it's been in gigahertz, megahertz. If that doesn't tell you about time, then I don't know what does. But essentially, anytime you have to have carrier frequencies and you have to manage carrier frequencies and switch between carrier frequencies, you have to time divide and you have to multiplex between carrier frequencies, and timing and synchronization is absolutely relevant. The second reason why it's relevant is almost every cell phone, the first thing you log in is you get your time of day. And if you don't have a time of day, you don't know which time zone you're in, which location you're in. Everything is related to time. So if you don't have a time, everything else is meaningless. So it's very, very critical for us to know location, as well as other parts of the information. And so timing is pretty critical.
Yeah. So when we talk about heterogeneous networks, one of the topics, really is small cells, and there's sort of two categories of that, right? There's outdoor small cells, and then there's indoor small cells. These are both areas that analysts such as myself and other firms have forecast that, we were going to have, who knows how many hundreds of thousands of small cells deployed by sort of about now, and we're not there yet. There have been some stumbling blocks. Maybe you guys can give us a quick picture of like where we are with small cells and why, this might be the year, or as we head into 2017, where we might actually really finally sort of cross the chasm with this and start to see some fairly significant deployments?
Yeah, so thanks, Mark. I think there's it's obviously a great point for those of us who lived through kind of residential femtocell. It was always, it was always next year's big thing, and we're still waiting on that one. But I think small cell has, suffered, if you will, from the same phenomenon, which is next year is always the big year. And I think we're starting to see definitive signs that that's coming. Quite frankly, I'm still not positive 2017 is the year.
Right. But what needs to happen, though?
Yeah, that's a good question, and I think you kind of segmented the question nicely. I mean, outdoor is a little bit different from indoor.
Yeah.
Obviously, the outdoor, in most of the mobile operators, and some of you are present here today, densification, network, urban infill, capacity adding, where picocells, microcells, things like that add value. That's starting. It's still moving slowly because, frankly, it's as much as anything else, just site act, backhaul, things of that sort. There's just the physical attributes. Sprint's announced plans to deploy 70,000 small cells. I'd question, I think we've seen reports on kind of how they're doing on that. It's tough outdoors, in terms of all the site act.
Right.
So you kind of bifurcate that. For us, the big market and where we see the big need is really on the indoor side. I think that's slightly different. What's needed there, though, to really drive that, and that's, again, where we're excited about some of the things going on with 3.5 in the U.S., is you need shared spectrum, so you can have neutral host capabilities, the ability to offer services for multiple operators over the same radio. Very common concept in Wi-Fi, but hasn't existed in practical form in cellular until now, and now that's happening between having spectrum that's not tied to a single operator, combined with the ability to support multiple operators over a single shared radio infrastructure in an economical way. We really see that as, the enablers for making indoor small cell happen.
Yeah, and that's really the point about indoor small cells. The technology's there, actually, in terms of the actual cells and the cost of them and so on, but there really is different business model needed in order to get that scalable deployment. Where would you say in terms of where are we now?
Yeah, I was going to add a couple of comments there. One was, I think, over the last, I've been tracking small cells for almost 7-8 years. Every time I go to Mobile World Congress, it's like, this is the year small cell is going to happen. And every year it doesn't happen. But it looks like in the grand scheme of things, small cells, or densification as I want to call it, is in preparation for really LTE Advanced and 5G, when retailers, indoor enterprises are rolling out newer services that actually take the capability that cellular brings indoors finally to bear, right? And one of the biggest problems they've had so far is the deployment challenges. For example, in order for it to get, at least I know for the synchronization part, they have to, if you're in a tall building like in Japan or in Tokyo, you have to get a legal license to deploy a GPS antenna all the way on the 30th floor. You have to get all the risk, you have to lease that site, and on top of that you have to run a cable which can run every cable $60,000, $70,000, and then you have to route it through different floors in order for them to get the signal. It's a deployment challenge that operators were facing. That's one issue. The other issue is running the power. So power over Ethernet actually helps them solve that. So now it's all managed through the same network. So now slowly all the deployment challenges for operators are going away. So they're able to go forward with their deployment plan. And then the third thing is operators are looking at this as a new way to increase their revenue streams so that they can go and deliver managed services. So then, they're moving forward with those plans as well.
Probably also means some cost sharing too, right? Where it's not always incumbent on the operator to spend on the deployment, that the enterprises have to have some skin in the game. They have to almost look at this like they looked at Wi-Fi for a while, which is they've got to spend some money on deploying some of the infrastructure, right?
Yeah, and that's a very important point. And again, all these things intertwine. It's a very complex ecosystem, a complex set of factors that need to be addressed to enable the market to really take off. As Mark said, the economics of it are huge. The operators certainly don't have enough CapEx, don't have enough OpEx, et cetera, to equip hundreds of thousands, tens of thousands of buildings, for instance, with indoor cellular. enterprises, for their part, they're willing to invest. They have problems. They want to provide good coverage indoor to whoever their customers are or whoever's walking in the door. But it has to be cost effective, similar to Wi-Fi, which means an easy deployment model. But also, again, back to what I said earlier, it has to support multi-operators. You can't have a hotel with 4 different small cells for 4 different mobile operators, for instance, in the US. That's not a viable model. So that's where all these things are intertwined.
So let's just, we've got about 5 minutes left, so let's spend a couple of minutes just talking a little bit about where Wi-Fi fits into all of this, because at the same time, lots going on with small cell, between LTE unlicensed, between multi-fire and, LWA. I mean, there's just a lot going on there too. So maybe we could just talk a little bit about Wi-Fi/unlicensed and where all that fits in.
Yeah, I mean, Wi-Fi continues to be really the radio access technology of choice for indoor. As all of us are aware, you almost can't go into a shop, a store, a hotel, whatever, without having Wi-Fi coverage today. It's becoming, like air and water and HVAC. You expect there to be Wi-Fi in places, and so that's continuing to advance. Is just really almost a utility as people expect it within whatever buildings they go into. And of course, it's continuing to advance with 11AC, 11AC Wave 2, 11AX, which will start to introduce almost some LTE type of timing constraints and things like that into the networks for Wi-Fi as it progresses. One of the areas that we're quite bullish of, back to the kind of Hetnet question, is LTE and Wi-Fi aggregation, LWA so-called, which was recently standardized in 3GPP. Really dynamically tying these networks together. I've been in this business for 25 years, and I think most of it I've heard about Wi-Fi cellular integration in many different schemes. But I think with LWA, we're really seeing a technology that actually works, and realistically, dynamically sharing between LTE and wireless LAN infrastructure in a really meaningful way that provides a better user, a much better user experience across a wide range of conditions. So I think, again, we see these networks coming together and being very complementary.
So I just wanted to add just 2 points. One was, I see Wi-Fi getting used more and more for capacity reasons, very hotspot, localized capacity, versus cellular being used for coverage and also managed services. So whenever you want seamless integration of services being deployed,
and QoS,
and SLA.
Yeah, exactly.
And so wherever you want the seamless handoff, you go to a cellular coverage, indoor, outdoor, integrated, whereas Wi-Fi is primarily for hotspot, very, very localized, high data rate throughput. So that's kind of the main distinction. So if customers are looking for services to be rolled out that are seamless, handoff, managed, you go cellular route versus Wi-Fi.
Okay, great. We have a couple more minutes, so questions. We have a microphone roaming around. Any questions from the audience on this?
We both did such a great job that there's no questions.
So while we're waiting on that, I'm going to ask you sort of a lightning round type question to put you on the spot. LTEU/LAA, will we have that in the United States in 2017, or is this going to go to multi-fire and 3.5 and?
LAA is going to happen.
Yeah.
Quite frankly, we're not big fans of LTEU. We have many public filings on that, as most of the Wi-Fi industry is not largely in favor. But LAA, it is definitely going to happen, and I think certainly Verizon's, perhaps T-Mobile, others are going to roll that out.
Yeah. Okay. Question? Yes, sir.
Yeah. So one of the things that Steve, you mentioned that with Sprint trying to roll out 70,000 small cells, they're having all kinds of problems. When you think about 5G, is almost exclusively dependent on rolling out mass number of small cells for densification. How's it going to change 2-3 years from now when they're ready to roll out 5G?
Great question.
I think that's a great question, and I don't know the answer to it. I see, as you talk about millimeter wave and all the things, the great technologies they're talking about for 5G, I see huge hurdles to adoption there or to widespread rollout because of just very practical stuff. Sure, the technology would be awesome, but you still got to get light poles, you got to get contracts, you got to get power. I mean, these are real problems.
If I can add one quick one on that is, I think 5G is really made up of 3 or 4 different elements. It's not just all small cells. It has an element of access technology where you go into higher frequencies, 60 gigahertz, etc. And then you have a densification aspect of it, and then you have the more distributed aspect of it where you have distributed radio and you have centralized baseband. So all of that together makes 5G. So just a comment.
And the one thing I'd sort of weigh in on this is that at CTIA, the major wireless show that happened a few weeks ago in Las Vegas, Tom Wheeler in his keynote address talked a little bit about that and said, like, one of the things we need for 5G now that we're sort of going to be allocating the spectrum for it is a model where we can get smaller cells deployed more quickly, and called upon the industry and called on the cable companies, called on enterprises and building owners to sort of facilitate a more sort of rapid deployment model for smaller cells. And we've seen this in some other countries. It's just been tougher here in the US, but clearly the FCC is sort of onto this. The question is how much can they force it, mandate it, and so on, versus just sort of call upon it.
Well, and I think this is where, the FCC with 3.5, but also looking forward to 5G, they've been very outspoken in terms of shared spectrum and spectrum sharing. Where this ties back into small cell deployment is being able to share radio resources. If you have to deploy 4 small cells, that's one thing. If you have to deploy 1 and share services, that actually creates a disintermediation, a secondary market for companies that are building out small cell infrastructures, for instance, that then have multiple networks over the top of them.
Just a follow-up question. Do you foresee the carriers, in order to deploy a lot of small cells, maybe go to a neighborhood and send emails to a neighbor or whatever and say, hey, if you want to put a small cell in your home, you get your 5G service for free or whatever, and that person becomes the small cell provider for the neighborhood, that kind of thing, completely bypass cities and all the other stuff.
So I believe a couple of, not tier 1 operators, I believe a couple of tier 2 operators are doing that today in Utah. For example, the one that comes to my mind is VIVE Wireless in Utah. They're rolling out in neighborhoods, close communities where they're rolling out 5G, they call it 5G access, higher data rate throughput. They're actually deploying smaller cells and in conjunction with 60 gigahertz, small line of sight. Interesting.
Yeah, I think you also see that. Obviously, just in the last couple of days, there's been announcements by Comcast, Charter, et cetera, in terms of their wireless strategy starting to come forward on that. And not that it's exclusive to them, but, you look on the Wi-Fi side, they're doing that today, right? Dual SSID, so-called phone model, if you will, that was pioneered by phone, but, effectively having your Xfinity Wi-Fi SSID that's broadcast by your 15 million subscribers. Taking that to small cell, I think is a logical extension, those same type of constructs. And of course, with the MSOs now, you're going to have strand mount. The MSOs have some advantages in terms of this whole SIDAC problem going in.
Exactly. Okay, well, I'm seeing we're a couple of minutes over time, so we're going to have to close this session out, but I think we actually covered a lot of ground in 20, 25 minutes. So thank you very much. It was a good session.